Okay, I want to talk to you now about conduit fill. Okay, I'll try to make this as simple as possible. And so, what's going to happen? I'm going to repeat myself several times so that I can instill in you the simplicity of conduit fill, let's say. So, let's get started. In the National Electric Code, table chapter 9, tables 1 here. And we'll get to that in a second. But let's take a look at conduit fill. Okay, let's talk about that. Let's start with conduit fill in regards to what we're trying to accomplish here. Because of the fact that you have power cables that can cause heat. Let's start this again. I don't like that at all. Okay. All right. All right. All right. Take a deep breath. On your Florida electrical exam, you're going to run across a few questions that relate to conduit fill. All right. Now, conduit fill is calculated, and what you're trying to do is you're trying to determine how many conductors or total area of conductors you can put into the total available area in a piece of conduit, tubing, or some other type of raceway. So, and you have to take into factor a reduction of the space available in the pipe based on the percentage of available fill based on the number of conductors. All right, now it sounds complicated, but it really isn't. Once you grasp this and understand it, it's pretty easy to figure this out. So I'm going to take this pretty slowly here and try to explain it to you step by step. Now, one of the things is on the Florida electrical exam, you might have questions that, for example, might ask you what is the percentage of fill for putting these types of conductors in these sizes. If the question specifically says percentage of fill, a percentage, the word percentage, if it specifically says a percentage of fill, then your percentage of fill answer is based on the number of cables that are inside the tube, that are going to be put inside the tube. Now let me explain that, and let's look at here at this reference that I have. And if you go to the NEC, you go to your in 2011, which is what is currently being tested on in Florida, you have chapter 9 tables, page 711. All right, and it has the cross-sectional area of conduit and tubing for conductors, table 1 at the top, and it shows number of conductors, 1, 2, and then over 2. You should have your NEC out, by the way, in order to do these calculations we're going to do and follow along with me. So you should have the National Electric Code out in front of you now with a calculator. Okay, so you can follow this. If you do this along with me, you should be fine with these. So if the question again asks you the percentage of fill, it doesn't matter what size the wires are. It doesn't matter how many wires are inside the cable. It matters as to how many cables are going inside the raceway or pipe. That's the percentage of fill. So if it's 1, then it's what? 53%. So if you have one cable, now it could be a multi-conductor cable. You could have 100 pair or 100 conductors in there, or 100 pair conductor in there. But if it's all under one sheath, you know, all those wires are under one sheath, that's considered one cable. Okay? So if you have one cable going into a pipe, you can fill 53% of the area available inside that pipe with that cable. Okay? So if you've got 2 cables, you can only fill 31% of that area inside that pipe. And if you have more than 2 cables, 3 cables and up, you can only fill 30%, or excuse me, 40% in that pipe. Okay. Now you may say, well, how come you can't use as much space with 2 cables compared to 3 or more cables? Well, the reason for that is that 2 cables have a tendency to twist around themselves when you pull them. They twist up inside the pipe, and so they give you less space to use. With 3 or more cables, they have a tendency to lay against each other, and you pull them through the pipe, and they're all straight. They're not wrapped up and twisted up. Okay, and of course, 1 cable, it's not going to twist with anything because it's only 1 cable. All right. So if they ask you the question of percentage of fill, it doesn't matter what type of wire it is. It doesn't matter when they're, and sometimes what they do on the exam is they throw quite a bunch of other measurements in there for you to kind of see if you really know what they're asking you. But if they ask you a percentage of fill, it's table 1, and if it's 1 conductor, it's what? 53% of the pipe can be filled. That's the area available inside that pipe. Okay, if it's 2, it's 31%. If it's more than 2, it's what? 40%. Okay, that's as simple as that. That's percentage of fill available in the pipe based on the number of cables going into the pipe. Okay, cables, conductors, same thing. Okay. They use the reference of conductors, but remember, a multi-conductor cable is considered 1 conductor, okay, according to the NEC. So I like to refer to them as cables, you know, so you just look at it that way. So that's as simple as it gets, all right, because you have to use that percentage of fill in your calculations later on, when you actually have to calculate out different conductor types and sizes and so forth. So here's a question. The maximum number of cables or conductors that can be installed in a single conduit is called what? Conduit fill, cable fill, conduit capacity, or allowable ampacity? Conduit fill. All right? Again, here's an example of that. Here's an example. So notice the note down, it says the total cross-sectional area of the cables must not be exceeded. Okay. Okay, now use the area of the cable to determine the area for raceway fill. Okay, so what you're trying to do here is you're looking at all the different pipes, all the tubing, all the different raceways. They have different internal diameters, okay, or what they call cross-sectional area. They all have different areas. All right. Now area is, how do you figure out area inside a circle? Well, you figure out area, let's take a square rectangle. In a square rectangle, you figure out area by length times width, right? You know, so it's just multiply those together, gives you your area, your total area available inside that rectangle or that square. But in a circle, you can't just go length times width or diameter times diameter because it's a circle, because the four corners, are missing, okay, because it's a circle, right? So you have to figure, and the simplest way to do this is to figure it out by taking area equals diameter times 0.7854. 0.7854. And you can see the diameter would be like, if you're comparing it to the length of a rectangle or a square, it would be the length times, let's say, the height or the width, right? But you got to reduce some of it because it's not all the way a square or rectangle. So you reduce it by 0.7854. All right, and that's how you figure out the area of any kind of pipe or of a conductor or cable, I should say. Okay, and the cables are measured from the outside of the installation to the other side of the outside of the installation, and the pipes are measured from the inside of the pipe to the other inside of the pipe. Okay, if you look on this example here, here's a cable. And you're going to measure the diameter times 0.7854 gives me my total area of that cable, okay? And on a conduit, you're going to measure what? The inside diameter times diameter, it's round, so it's going to be the same number, times 0.7854 as well to get the inside of the size of the conduit. Now, fortunately, the NEC tells us a lot of this stuff, so we don't have to do the actual calculations here. Now, here again, I note that a multi-conductor cable is considered a single conductor for calculating conduit fill. I mentioned that earlier. So it's really, here's a solid conductor, just a single conductor there. It's from the outside to the outside. Diameter times 0.7854. And here's a piece of Romex. And in Romex, you take the largest ellipse, the flat part of a piece of Romex, and that's the diameter you multiply twice. So it's diameter times diameter, see that, times 0.7854. And it gives you your area of your conductor, okay, or your cable. So here's a better representation of that. Here's your cables, right? You're trying to calculate, you got to calculate the area available of all the cables. So if you're putting more than one, you calculate out one of the cable's area and add it to the calculation of the next cable's area. And then you're going into a piece of conduit, so you've got to calculate how much area you have available. And then, based on the number of conductors or cables going into that conduit, you have to reduce it by the percentage of fill. Okay, now some of you have probably lost already, but let me keep going with this. So just follow me on these examples here. Here's your conductors your cables going into your pipe. So you can see where you're calculating. That's a piece of Romex there. That's a multi-conductor there. I've got to calculate the total area there. I've got two of them going in there, right? So I go back to table 1. If I got 2, I can only fill that 31% of area available, right? Of that conduit. Okay. All right, let's do some examples here. And I think doing these examples will help you understand this a little bit better. So here we go. What size RMC do you need to run 3 1/2-inch diameter multi-conductor cables? Okay. First of all, what's RMC? Okay. Rigid metallic conduit, right? Okay. So when it comes to these exams, you're going to get acronyms like this. You're going to have to know what these acronyms are. And those can be found in the table of contents. In the front of the book, it lists all the different acronyms for the conduit and raceway types, okay? So I know I'm gonna. It's asking me. They're asking about one pipe, right? One pipe. What size RMC? Do you need to run 3 1/2-inch diameter multi-conductor cables? All right. So I know I'm going to use one pipe, but I know I'm going to run 3 multi-conductor cables. So now what I need to put in the back of my mind is, what is my available percentage of fill? I'm just going to keep that in my mind. Since it's over 2 conductors, I'm going to only be able to fill what? 40% of that pipe, right? If you look down here on the NEC table 1, it tells you I can only fill 40% of that pipe. I'm not going to use that yet. I'm just going to keep that in my mind. I got 3 cables going in there, conductors, and I only going to be able to put, I got to reduce down 40% of that pipe. Okay. So I'm going into RMC. So the good thing about it is the NEC gives you all the areas already calculated based on the type of raceway it is, whether it be a piece of tubing, whether it be a piece of conduit, EMT, RMC, whatever. The reason they do that is because you see all the interior diameters of these different pipes aren't the same. For example, when you say trade size 1, that basically means a 1-inch pipe, right? But the inside diameter is on a trade size is not always the same. They don't exactly have the same measurements. So you have to look these up based on the type of pipe it is or raceway it is, and you'll look at the table there. So let's keep that in mind. We know it's RMC, and they got to tell you that. And we've got 3 1/2-inch diameter multi-conductor cables. So now the first thing I need to do is figure out, I got 3 cables. I got to figure out what the area for each of those cables is. And the area for the cable here on 3 would be what? It's 1/2 inch, which is 0.5, right? 0.5 times 0.5 times 0.7854 gives me my area per 1 cable. All right? So 0.5 times 0.5 times 7854 equals 0.1964. That's my total area for 1 cable. However, I don't just have 1 cable, right? I got 3 cables. So I got to multiply that by 3, and that gives me my total area, all 3 of those conductors or cables added together, right? And that comes out to 0.5892. Let's go back there again. The first thing I have to do is figure out what my area is of my cables I'm going to be putting in, my total area. So I take 1 cable, and they told me the cable itself is 0.5, is 1/2 inch, and I got to figure out the area of that. So I just use my formula, diameter times 0.7854, and I come up with what the area is for that 1 cable, which is 0.1964, right? Now, but I got 3 cables going into that pipe, that RMC. So I got to add them all together because that would be the total area. So I add 0.1964 3 times, or multiply by 3 times. I come out with 0.5892. Now, I know what my cable is going into my pipe. I know my type of pipe is RMC, right? I know I got 3 cables going in there, and I know the area of those cables, because I totaled it, and that's 0.5892. But they're asking me how big is my RMC that I need. Well, my RMC comes in different sizes, all right? But I gotta figure out how am I gonna figure out my RMC and the size and getting that cables in there. It's simple. What you do is on table 4, okay, table 4, page. Actually, if you're on page 711. Go ahead and turn to the next page. Table 4 starts to give you your references for all your different types of raceways. You can see on page 712 at the very top, table 4, at the very top is Article 358. By the way, Article 358 corresponds to the article in this book that goes into specifics about that type of tubing. electrometallic tubing, EMT, okay? So you can look back at article number 358 or chapter 358, however you want to say that, and you could look into the electrical metallic tubing and find out different things about that. When you secure and support that, what's the distances of your supports and things of that nature. So that gives you the reference to the actual chapter where that is referenced there. So we're not looking for EMT though. We're looking for what? RMC, right? So where's RMC? RMC, turn to the next page. There it is. It's on page 714. You have RMC, right? And it's in the middle of the page. All right, now let me go to this a little bit closer view of this if I can for you. There you go. So RMC is right here. Now, it's asking me what size pipe I could use. Well, here's all the trade sizes off to your left here. Notice across here, it does give me my total area. They already calculate and tell me my total area of the pipe here, right? And what do I have to the right of that? I have my percentages of fill based on the number of wires going in there. And remember what we said, we got how many wires going in here? We got 3 cables going in here. So we're going to be over here at this table here. That's why I told you earlier, remember that, keep that in your mind. 3 cables over 2 wires, okay? We're over here. Now, let's go back to the question. And it says here, okay, trade size, what? It's just, I'm actually just asking. Okay, here's what we got. So, RMC 0.5892 is the total area of the cables that we have. So what we have to do is it's asking us, you know, what size RMC. So we've got to put these cables of that much area into the RMC pipe. But what do we got to do? We got to base it on a reduction of the fill. So we come over here. It's inches squared, not millimeters, by the way. This is not what we use in the United States. It's inches squared for the area. And we've got 0.5892, because remember, we got 3 wires, so we can't look under here because that's for 1 wire, that's for 2 wires, and this is for over 2 wires, so we got 3 wires. So we come down here and we say, okay, well, we're going to be having to put in 0.5892 cables. Where are we going to put that? 0.355 is too small of a pipe. 0.610 is perfect because it's big enough to fit that. So it can either be exactly the same number, 0.5892, or it can be higher than the number. It can't be lower than the number. Okay? So the 4th one down, and if you take a straight edge here somewhere, which I don't happen to have one handy, but you should have one. Let's see, straight edge there, you go over and you look at the trade size, and what does it say? 1 1/4. 1 1/4 trade size pipe will fit those 3 conductors. There you go. Okay. You have to base it on the percentage of fill reduction based on the number of cables going into the pipe. Let's take another one, a little different one here. What size EMT do I need to install 3 12 AWG THWNs, 4 10 AWG THWNs, and 8 AWG THWN conductors? Okay. Now, what size EMT? Same thing as asking me before, what size, RMC? I'm talking about one pipe here. What size EMT do I need to install 3, 12, and so forth? Okay. So I know I'm going to do what? I know I'm eventually going to go to what? EMT. So where's EMT? EMT is on page 712. It's right there. So it's on page 712. I'll keep that. I'm installing how many conductors here? And you can see a picture of those. So those are individual strands. They're not in a cable, overall cable sheath. So I got a whole bunch of them there. So that's well more than 2. So I know what I'm going to do. I'm going to be at, what, 40% fill, right? I'm going to be right here at 40% fill. So I got Article 358, electrical metallic tubing, EMT, and I'm going to be at 40% fill. So I know that. So now what I got to do? Okay, now I got to figure out the what? The area of those conductors, right? I got to figure out the area of those conductors, but they're not telling me the area, nor they're not even giving me a measurement to me to calculate the area. They at least tell me the diameter of those wires. I can calculate the area, right, myself. But they're not. They're telling me the number of the conductors, but what are they telling me there? They're telling me the type of wire it is. Now, type of wire. Okay, the NEC comes to our rescue again, based on type of wire. All right. Table 5. Keep your marker there on table 4. Keep like a pin in here or something. And let's go to table 5. This is all table 4. This is all table 4. Here's table 5. Now, we have, and I'll flip this back here. Table 5 starts on 716. Okay? And if you look at the left-hand side of table 5, you'll see all the different types of conductors, you know. And we're looking for THWNs, okay? And let's keep going here. TAH, THWN, right there, okay? On page 718, right there. And what does the NEC do for us? It actually calculates out this type of wire based on their wire gauge, okay, what the area already is. Okay, they give us the diameter and we could calculate it ourselves right here. But why do that? They give us the area over here already. Okay, so we got to look in, and let me kind of go back here and see if I can get this on the screen at the same time. Yeah, let's go there. Okay. And based on the type of wire we got right here, THWN, this is all THWN, okay? We have, it said in the question, it said they had 12, let's go back to the question. Okay. Forgetting about right now how many there are, okay? We got 12, they're talking about gauge. 312 AWG, American wire gauge, right? THWN, and then 410 AWG. So we got to find the diameter. We just got to find out one of the areas for each of these, and then we can come back and multiply it by the number we have. So we need a 12 AWG THWN, a 10 AWG, and an 8 AWG. Okay, so let's go back to that. Okay, so 12 AWG type THWN. Here's THWN, and we've got right next to it is the AWG. We've got a 12, and we got to use our straight edge. And that's one thing about the exam is, and I usually give these out in our packets, but if you don't have one, cut yourself some little cardboard strips, just little strips of cardboard, and put them in there like bookmarkers. Don't write anything on them. Put them in there as bookmarkers so they won't take them. If you write something on them, it might take them. So then you can use them as straight edges, because you get into this tables on the NEC, or you take a piece of paper and fold it up, or you could use your scratch paper. But your scratch paper you're going to be using, and it's going to be plastic. It's going to have all kinds of dry erase marker on it, and you're going to get it all off your hands and everything. So you're better off carrying some of these things with you and put them in each book, so that you can use a straight edge to be able to go through these tables and figure out where you're at there, because otherwise you get off. It's so easy to get off on these things and to make a mistake. So I'm looking at 12 So I got to write down my area on that is 0.0133 right there. And then I got another one is a 10. In 10, the area on that is 0.0211. You should be writing these down. And then I got an 8, and the 8 on that is 0.0366. Okay. So those are the areas of each of the, right there. Okay. So that's what I did. But we've got more than just one of these. If you go back to the question says we have 3 12s, 4 10s, and then 8 8s. So when you go down there, you got to multiply. These are just for one, so you got to multiply those by the number there. So it was 3 12s, 4 10s, and 8 8s. So each individual 12 is 0.0133. Each individual 10 is 0.0211. And each individual 8 AWG is 0.0366. Multiply that 3 times 0.0133, 4 times 0.0211, 8 times 0.0366, and it'll come out with your total area per those particular gauges. Then you add them all together and you get your total square footage. Okay. All right. So then you've got those times 12, and you, where are we at here? What's going on? Okay, there we go. There you go. Okay. 3 times 0.0133 is 0.0399. 4 times 0.0211 is 0.0844. 8 times 0.0366 is 0.2928. Those are for your individual gauges. Okay, and then you add all those together and you get a total area of that all your conductors or cables are going to take up is 0.4171 square inches, right? Okay, now you know how many your space of all your conductors is going to take up. And what do? You got to go back to your table because we were looking at what? We were looking at EMT, weren't we? Mm-hmm. And that was on page 712. So I go back to, I know 0.4171, right? And I know I got to be in what category? 0.4171, and I got to be in what category? 40%, right? All the way over to the right. It's up here. Article 358, electrical metallic tubing, EMT. And we know all our wires are taking up a total area of 0.4171 square inches. And since there's more than 2 wires, it's 40% filled. So I'm over on this table here. I come down and I've got 0.4171. So 0.348, the third one down, is not big enough. 0.598, that's big enough. So I go to 0.598 right there. That'll fit in there okay. Then I take my little straight edge and I go across here and come all the way over to trade size, and I need a 1.25 or 1 1/4 inch pipe. Okay. All right. So there you are. 0.384 is too small. That's 1 inch, and then 0.598 will fit. The 0.41 will fit into that. You can always get a bigger pipe, but you can't do a smaller pipe. Okay. So it's not really ever going to be exact. So, but it's always going to probably be a little bit bigger. So that's what you do. And you round up to the next size. Always round up to the next size. Okay. All right. If you have any problems with these, and this might be going a little bit further than what you'll have on the exam. The first one was more likely what you'll have on the exam. But you need to know this. Number one, if you're going to be in the trade. But also, there could be questions that come to this, use table 4 and so forth. What I would suggest you do, the technical test is not easy. I would do the calculations towards the end. I do all my other stuff first, and mark down the calculations and what I got to do, what the question number is, and come back to those at the end and do them all at the same time. So you're in that mindset where you're thinking about the calculations. You got the book open to that section, and you're doing them all, knocking them out. You might not have that many, but you could have 3, 4, 5. Okay, so it is something you got to know. If you, for some reason, as we move forward, I'm going to do a couple more for you here. But if you have a problem with this, drop me an email, give me a call. I'll send you out a guide that goes through this whole thing, and then you can do more questions if you want. Okay, but if you understand this, then you're in good shape with conduit fill. Let's keep going. Here's another question. That's the answer. 1 1/4, right? Okay. Here's another question. How many number 12 THHN conductors can be installed in a 3/4 inch rigid metal conduit? Well, that's pretty easy. Oh, okay. This is kind of the reverse. It's not asking us for the size of the pipe like the other ones have been asking us. It's asking us how many conductors can we put in this pipe, because we have, I guess, this pipe already installed or so, and we're going to put these conductors in here. We want to know how many we can run inside this pipe. Let's see. Okay, well, that's going to be easy then. Begin by referring to Annex C, Table C8. Oh, yeah, well, here you go. Actually, let's go back to the question. Another thing that the NEC does for us is they make our life a lot easier when it comes to these different types of conductors and the number that can fit inside a pipe, okay? And you would go, try to remember this. How many number 12 THHN conductors can be installed in a 3/4 inch metal conduit? Okay. Annex C. Okay, Annex C is on page 744. Let me try to get this in here. Annex C 744. And let's go look at this. This says a conduit and tubing fill tables for conductors and fittings, fixture wires of the same size. So if the wires are all the same size, right, of these certain types of wires, then again, these are not multi-conductor cables, you know, that we're used to in the low voltage trade. These are higher voltage cables. It could be firearm cables, but still, these are usually power conductors that we're talking about here. Okay. So if the wire sizes are the same, they've already done all the calculation for us. So what do we have to find here? We have to find the type of what? Type of pipe. Okay. So let's go down through this chart here and see what we're looking for. RMC. RMC. Where's RMC in here? RMC. Rigid metal conduit. What page is that? 780. Let's go to 780. 780 RMC. Okay. Maximum number of conductors or fixture wires in rigid metal conduit. And the question was what? How many number 12 THHNs conductors can we be installed in a 3/4 minute rigid metal conduit? Okay. So first of all, we know we got to deal with RMC right here. Okay, RMC on page 780. Now, we're going to look at type of wire next, THHN. Where are we going to find that? Next page, THHW. Okay, THHN on page 789. Next page, right there. And number of conductors and pipe size. Okay, across the top is what? Pipe size, trade size, right? Okay, and we're looking at a 3/4 inch trade size, right there. Second column there. Okay, and we got how many we're going to be able to put in there. They'll be down here. Conductor size is number 12. So number 12 is here. We can put in intersection there is 16. Okay, let me just show you that a little closer up maybe. Okay. So we know number one that we're looking for the rigid metal conduit. Okay, all the conductors are the same size. Rigid metal conduit, we go to that section, Annex C. Then we look for the wire type. Okay, wire type's on the left-hand side, THHN. It's on page 781. We're still under rigid metal conduit. All right, and then now we got they're asking how many can we put in a 3/4 of an inch trade size pipe. Well, trade size is across the top. See, trade size, 3/4 of an inch right there. You follow that down to the type of wire, THWN, and it tells you right there based on the number, based on the size of the conductor now. Number 12, see that? THWN, number 12, and it's 16. If it was a number 10 size conductor, 10 AWG, it would be 10, right? If it was 14 AWG, it would be 22, right? See that right there? Okay. So the answer then is, what did we say? We said 16, right? 16 right there. Okay. 16. All right. All right. Let's do this one. This is the last one we're going to do. This one is actually... Oh, wait a minute. I got two more to do. We'll do two more. Okay, this one. What size EMT conduit will be required for 16 category 5 cables with an outside diameter of 0.24 each? All right, okay. Where are we going to start with this? Well, first of all, 16 category 5 cables, right? Multi-conductor cables. I know what? Fill, what's the percentage of fill? Percentage of fill is table 1, right? More than how many? Over 2, it's what percentage of fill? 40% fill. Over 2. So I want to put 16 in there. Well, that's more than 2. So I keep in the back of my mind, that's 40% fill. I got to go to that side of the tick chart. What size EMT conduit will be required for 16 category 5 cables with an outside diameter of 0.4 each? Okay. Well, I know I'm going to use EMT, so that's going to be table 4 for EMT, right? Let's just go there. Table 4, EMT. Well, it's right at the top on page 712. And I'm going to be over here in this 40% area right over here. Okay? That's on page 712. So that I know EMT. They're asking me what size, trade size of EMT, which is right here. So I got to do the old calculation here. Now, what do I got to figure out? I've got 16 category 5 cables, okay? And they're telling me the outside diameter is 0.24 each. All right, well, that's easy then. What do I got to do? Well, I got to calculate the total area for those cables. You know, there's 16 of them, so I just got to do one of them, then multiply them by 16. So it's 0.24 is the diameter. Formula is what? Diameter times 0.7854, right? Keep it simple. So 0.24 times 0.24 times 0.7854. Do that on your calculator. That's going to give me the area of one cable, right? Right? And what is that? That's 0.045239. weird. What's going on here? No, that's not right. 0.24 times 0.24. Oh, okay. I'm sorry. I don't know why this is broken down like that, but it's 0.24 times 0.24 times 0.7854, and you have 0.045239. Okay. And that's the area. I took it out quite a few decimal places there. That's not necessary, but to get it more accurate, you could bring it out more than 4. So I brought it out 5. Yeah. So I went 5 on the calculator. Then you multiply it by what? 16, because there's 16 conductors, right? Cables. So you come up with 0.723824. So 0.7238, or you go 0.724, okay? And then what am I going to do? I'm going to go back to my electrical metallic tubing, EMT, on page 712. I know I got 16 of them, so that's 40% fill. So I'm going to look down here. I got to find a number that's higher than 0.7238. Exactly that number or higher. So 0.7 looks like it's the one on here that I see is 0.814. Okay, and if I take my straight edge here and go over, terrible straight edge, it's a mouse pad, but anyway, it's 1.5. Is that right? 1.5. Everybody got that? 1.5. Let's see what the answer is here. Yep, there it is. 1.5. Okay, you can't see that. Try to get that back there. Okay, 1.5. So that's that. Okay. All right, well, that's going to be a wrap for this conduit fill. If you have any questions on this, please, drop me an email, give me a call, and I will. I'll send you some more information. If you have some specific questions, I could probably answer those over the phone for you. So, in any case, thank you very much.